So we're going to continue with our overview of some of the common intermediate operations that are available in Java streams, focusing at the moment on filter and flatMap. And these are two very interesting intermediate operations. They are both stateless, run-to-completion operations. So that means that they don't have to take into account any history of anything, and they continue to run until everything's processed or an exception is thrown or a terminal operation has a short-circuiting behavior. But left to their own devices, they will continue to run over every element. We're also going to discuss some curious limitations with the flatMap operator, which is kind of fun. And I'll walk through a program that illustrates some of the limitations. It's very curious indeed. So we'll start by talking about what filter is. Filter is something you're going to be doing a lot of. And so what filter does is it tests a predicate against each element of an input stream, and it returns an output stream containing only elements that match the predicate. So it's kind of like filtering something like flour or water or something. It's filtering things that you don't want to pass through the filter and only allowing things you want to pass through the filter. Now, one of the curious, or not so much curious, one of the interesting characteristics of filter is that the number of stream elements from the output of filter can very well be less than the number of input stream elements. Now, if every single element in the input stream matches the predicate, then it'll have the same number. The output stream will have the same number as the input stream. However, if the predicate doesn't apply in some cases, then you'll obviously get fewer things out. That's the purpose of filter. So here's an example where we have applied that in the context of our running case study, the simple search stream program. And you can see here that we use this to get rid of empty search results. So if it was the case that something didn't match, if we looked for a word that was not in the input string, then filter would remove the search results that have nothing in them, because we don't want to be wasting our time with something that's not there. You'll see some other interesting examples of using filter when we look at the case study here shortly. One of the other important things to remember about filter is, unlike map and flatMap for that purpose, for that reason, that can modify things and change the types or the values, filter cannot change the type or value of elements it processes. They're just either provided as whole or they're not provided at all. They don't get changed. Here's just looking at the code. Notice again the typical fluent interface style. And this is also fun because we're negating the results of the isEmpty. So remember, filter always allows things that match the predicate. So if we want to get rid of empty stuff, we have to allow things that are not empty. And sometimes that takes a little getting your head around it first because it's kind of curious. OK, so that's filter. Very straightforward, very useful operation. And we'll see how it gets applied shortly. Let's now talk about something even more interesting, the flatMap operator or operation. And flatMap returns a stream that replaces each stream element with the contents of a map stream produced by applying the provided mapping function to each element. Now, when you first see this thing, this definition, you may say, gosh, that sounds like map. But there are some really important differences between map and flatMap. And the name flatMap kind of conveys some of those important differences. So here's, in a nutshell, the key difference, or one of the differences. So if you recall, map, unless something goes awry, will always have the same number of elements in the output stream as the input stream. So if there are 100 elements coming in, after applying map, there'll be 100 elements coming out. Again, assuming no exceptions or other problems. In contrast, flatMap may have an output stream that differs from the number of input stream elements. So you might have more elements. So if you had 100, you may end up with 200. You might have less. You might end up with 10 instead of 100. Or in some circumstances, you'll end up with the same number of elements. But most commonly, there's often a different number of elements from the input and the output. And the way this is often used is to flatten the input that comes in. And we'll see some examples of this in short order. But here's one example. Let's say that we had a stream of arrays of lists of strings. So we have a stream, or rather a stream of lists of strings. Let's say we have list 1, list 2, list 3, up to list n. So we've got n lists of strings, and we have an array of that. So that's what of is dealing with. You have an array of lists of strings. And after running the lists of strings through flatMap, we'll end up with a stream of strings. So what flatMap is doing is it's pulling things out of the lists and flattening them. So you'll end up with a stream of items as opposed to a stream of lists of items. And there's a bunch of circumstances under which that's very, very useful, and you'll see some examples here shortly. Like map, flatMap can modify the type and the values. So if you so choose, you can change the types. So in this case, we're having a stream of lists of strings, and we end up with a stream of strings, so in some sense, the type's being changed. And here's an example. This is that example I was just mentioning. We have a bunch of lists of strings, and here we make a stream of these lists of strings, and then we flatMap that into a stream of strings. So it's been flattened. And that's why I always like the steamroller metaphor, to flatten things. Obviously, it doesn't have quite the effect that running a steamroller does over something, but it flattens it out. All right, so that's flatMap. We'll get a chance to play around with flatMap in various ways. Now, something important to remember when you're exposed to flatMap is it has some rather particular quirks. It's very useful in a lot of situations, but it has one particular limitation that's very important to understand. And the limitation is that you can only do sequential processing with flatMap. This is not a very well understood limitation, so that's why I'm spending some time on it. Now, I realize we haven't really gotten into the parallel stream stuff in earnest. We've talked a bit about what parallel streams are, and you're going to get more experience here shortly. But you typically use parallel streams when you want to make things run in parallel. It would stand to reason, right? Well, it turns out that if you look at the implementation of flatMap, that flatMap will force all the inner streams, and I'll explain what that means shortly, to be run sequentially. So it's actually not useful in a parallel program. Very quirky. So here's an example. I'm just going to go through this quickly because we're going to walk through the code here in a second in detail. But what we're trying to do here is we're trying to have an outer stream that runs in parallel, and then we're going to have an inner stream that's trying to do some stuff also in parallel. And despite the fact that we have the .parallel directive here, operator here, this inner stream is always going to run sequentially, even though we said I want it to be running in parallel. Rather quirky and rather curious, isn't it? Now, the solution to fix this is quite simple, also very idiomatic, but quite simple. We get rid of using flatMap for the inner stream, and instead we use map followed by reduce stream concat. And if you do this, you will get the behavior you want, which is to be basically flattening things, but everything will run in parallel. So it's very quirky, but very interesting. So I won't spend a lot of time on this example because we're about to walk through the code, but I want you to see the high-level view in case you happen to watch this video by itself to understand that flatMap doesn't work in parallel streams, but you can solve the problem by a clever combination of map and reduce with stream concat. OK, so that's the overview of filter and flatMap.